Hello students, in this today's lecture we will discuss the part B section of relation between line voltage and phase voltages in star connected loads. So this will be the B bit called relation between line currents and phase currents. Line currents and phase currents. So since it is a star connected load, since it is a star connected system, since it is a star connected system, since it is a star connected system, line conductor is connected to a separate phase. Line conductor is separated as separate phase. So the current flowing through the line and phase are same. For example, this is the star connected load. So this is the line current. For example, this is R phase, Y phase and B phase. This will be the line current through R phase. This is the line current through R phase. Line current and phase current. Phase current means if I take a neutral from this point, if I take a neutral from this point, neutral, this will be the B phase, Y phase. Then if I connect any load here, if I connect any any fridge or any appliance, connect here at this point, then the current which is flowing through this part will be the phase current. Phase current. Okay, that is called IRL. Hope you understand this point. So here, line current and phase current both are same in line current and phase current both are same in case of star connected load. In case of star connected load, this point you have to keep in your mind. Okay, line current and phase current both are same. That is nothing but IR is equal to IY is equal to IB is equal to the phase current. That is nothing but different phases like R to neutral, Y to neutral, Y to neutral, B to neutral. Okay, hope you understand this point. So that was the part B, relation between the line currents and phase currents. Then the other point will be, C bit is called power. Okay. So the power will be, if the phase current has a phase difference of phi with phase voltage, if a phase has, if a phase current means always you have to remember one line to neutral, one phase current, either it may be, L may be either R, Y, B, any phase, sorry, any line to neutral is called phase. Okay, if the phase current has a phase difference of, if the phase current has a phase difference of, phase current has a phase difference of phi with the phase voltage, with phase voltage, always remember phase voltage means phase, one line connected to neutral. Okay, one line connected to neutral. Line may be either R, Y, B, any line. Okay, then the total, then the power per phase, then power per phase will be, power per phase will be, what is the power per phase there? Phase voltage into, because we are finding the power per phase, means voltage per phase voltage into phase current, into what is the phase difference. Difference is there, no? To find the difference, we have to find the cosine of the angle between these two values. So cosine of the angle between the voltage and phase voltage and phase current, cosine angle. So this can also be written as phase voltage into phase current into cos of the angle between the phase voltage and phase current. Hope you understand this point. This phi is nothing but the phase angle between the voltage and current, phase voltage and phase current. So that was the power per phase. We also have one more power called true power. True power. Okay. What do you mean by true power? True power is nothing but we have to find, this is per phase, no? The power for per phase. If you want to find the power, true power, then three phases multiplied by 3. Means this is 3 is multiplied, this 3 factor is nothing but we have 3 phases, so the multiplying factor will be 3 into power per phase, into power per phase. Hope you understand this point. That is nothing but 3 into E phase into I phase into cos phi. Cos phi. Okay, this is nothing but the true power. True power. True power. If you want to find, instead of finding the phase voltage, if you want to find the line, this is in terms of phases. If you want to find in terms of line, in terms of line means what is line voltage in case of star? Root 3 times phase voltage, no? Then phase voltage can also be represented by line voltage divided by root 3. Am I correct? Yes. And in the same way, line current and phase current both are same. Just now we have described. Okay. Then replace this phase voltage and phase current by line. Then what we get here? That implies 3 into phase voltage is nothing but line voltage divided by root 3 into what is the phase current? Phase current and line current both are same, into cos phi. Then what we get here? This root 3 out of 3 times will be get cancelled here. Then we get root 3 times EL into IL into cos phi. This is nothing but the true power. Hope you understand this point. These are the two formulae. Where you have to use. If in terms of phase voltages are given, phase currents, in terms of power in terms of phase, is this formula 3 times E phase into I phase into cos phi. You can see, no, there is no line, but this formula is used only for when everything is given in terms of line. If you want to find the power, find the power in terms of line. This is the power in terms of phase, per phase. Okay, hope you understand this point. And also we have one more power called apparent power. One more power called apparent power. Apparent power. What do you mean by apparent power? Apparent power is nothing but, in case of star connected load, this is apparent power is nothing but 3 into, that implies, let me write here, that is equal to, we are finding for total power, means we have to multiply for 3 phases. 3 into what is the power we have described here? Yes or no? What is the power we have described here? 3 into 3 into E phase into I phase. Okay, hope you remember this point. This is what we have to remember. Okay, this is the formula we have to remember. So 3 into E phase into I phase. There is no angle between power factor and, sorry, there is no angle between the voltage and current. This is what the apparent power. This is what the apparent power. If you draw a triangle like this, if this is the true power, this is the reactive power. Reactive power is generally represented by Q. Then this is nothing but the apparent power. Apparent power. Hope you understand this point. Apparent power is always represented by or denoted by capital S. Okay. This true power is nothing but 3 into V phase into I phase into cos phi. Then this will be reactive power is represented by 3 into V phase into I phase into sin phi. Then you apply the hypotenuse right angle triangle theorem. Right angle triangle theorem. What is right angle triangle theorem? Hypotenuse square is equal to opposite square plus adjacent square. And what we get here? Sin square alpha, sin square phi plus cos square phi will be what? 1. Then what we get here? 3 will be a common factor. Yes or no? 3 into V phase square into I phase square. Then the square will be over this one. This square to the other side will be what? Root. Square and root will be get cancelled. This will become 3 into V phase into I phase. So that is what I have written here. Okay. So that implies so that is the apparent power is equal to 3 into E phase into I phase, 3 into E phase into I phase. Then 3 into, so this is in terms of phase. In terms of phase, if you want to find in terms of line, in terms of line means then the phase voltage or the line voltage in terms of line in case of star connection load. Since we are doing for star connected, no, line voltage is equal to root 3 times the phase voltage. Then phase voltage is equal to what? What is the phase voltage? Line voltage divided by root 3. And what about the line current and phase current? In case of star, both are same. Okay. So substitute these values in this equation. Then what we get here, line phase voltage is equal to line voltage by root 3 into what is phase current? Is nothing but the line current. Then if you simplify this, apparent power S is equal to what we get? 3 out of root 3 will be root 3 into EL into IL. So this power is the apparent power in terms of line. So this is the apparent power in terms of phase. Hope you understand this point. Clear? Thank you.